Today, we're going behind the digital curtain. We're doing a deep dive into one of the most underappreciated threats to uptime, the physical environment itself.
Exactly. We're talking about the silent killers. A tiny drip of water or, a server room that's just a few degrees too hot.
So our mission today is to really analyze this piece of hardware, the NTI E-MICRO-TRHP-TAA. It's a monitoring system.
It is, and it's a perfect case study in resilience. It helps us understand what it really takes to protect critical infrastructure from the mundane. We're talking temperature, humidity, water, power, even intrusion and smoke.
Okay, let's unpack this then. If this is the guard dog of the data center, what are its eyes and ears? I see it's got an integrated temperature and humidity sensor, but that can't be everything, can it?
No, you're right. And what's fascinating here is how it maximizes coverage without, overcomplicating things. You get that internal sensor, sure, but then you have two additional RJ45 ports for external sensors.
So you could monitor, say, the top of a rack and the bottom, or a room down the hall.
That's the idea, maybe a distant battery room or just different thermal zones. But the real first line of defense is often about things like floods or someone opening a door they shouldn't.
Right, those simple binary signals. What about those?
That's where the two dry contact inputs come in. Think of them as just simple on or off switches.
So you could hook up a door alarm.
A magnetic door alarm, an AC status relay, or, and this is crucial, a liquid detection sensor. The second it detects water, the circuit closes and the alarm goes off.
And these are all hot pluggable.
All hot pluggable, which, that saves a massive headache during a live installation. No need to power down.
And what about accuracy? For compliance and just to avoid false alarms, you need precision, not rough estimates.
Oh, precision is the entire point. If your readings drift, you either get costly false alarms or, you miss a real problem. The temperature accuracy is specified at a really tight plus or minus 0.4 degrees Celsius.
So you're not shutting down systems just because the sensor's guessing. Okay, that makes sense for detection. Now let's talk resilience. This gets really interesting. If this unit is supposed to monitor failures, how does it make sure it doesn't fail?
That's the key question, isn't it? And that perceived complexity is actually its greatest strength, at least in this TRHP model we're looking at.
It has triple power redundancy.
Triple power. You have dual DC inputs plus power over Ethernet, PoE. So if a power supply fails, the unit just coughs. It automatically switches to the next source.
Without any interruption.
Without any interruption. And that PoE is great because it simplifies the wiring and you're getting guaranteed quality power right from the network switch.
So it's physically ardent. What about its digital vigilance? It's on the network, so it has to know the network is even working to send an alert.
Right. It performs its own health check. The unit can be configured to ping up to 4 other critical devices on the network.
Like a router or a key server.
A router, an adjacent server, whatever you need. If one of them stops responding, the monitor can alert you. So it's watching the environment and the network at the same time.
So how does all this intelligence actually become, actionable information for a manager? You don't want 32 separate alerts hitting your phone at 3 a.m.
And that's where the customizable alert system is so smart. You can configure up to 32 individual alerts, but the real value is in the smart alert.
A single alarm based on combined conditions.
Precisely. For example, you only get an alert if the temperature is high and the door contact is closed. That could point to an environmental fault and an intrusion attempt happening together.
That prevents alert fatigue from, a minor flicker in the numbers.
Exactly. And it communicates across every channel you'd want. Email, web page, SNMP traps for your network management system, syslog.
And I assume it's secure.
It has to be. HDTPS, TLS v1.2, AES 256-bit encryption, 16-character authentication. It's built for sensitive, often completely unmanned areas.
So to recap, we've got multifaceted sensor inputs, triple redundant power, and really advanced intelligent alerting.
So here's a final thought for you to consider. We invest so much in digital firewalls and cybersecurity, but how do we actually quantify physical risk? This unit's mean time between failures, its MTBF, is rated at over 577,000 hours.
Wow.
So the question is, does knowing the precise statistical reliability of the monitor itself change how you calculate your service level agreements? And how does that shift the priority you give to physical protection versus virtual?